Okay, this lesson is on solving two-step equations. We just finished solving one-step equations, so right now we're going to combine the two together. I refer to two-step equations as the sock and shoe method because we have to do things in reverse order of the order of operations. So just like we put on our socks and our shoes, the first thing we do is put on our socks and then our shoes, and in order to take them off, we have to take them off in the reversed order. So for the first example, you're going to notice that I have a couple different things here. So the first thing that would happen with the order of operations is we would do our division, x divided by 8, then we would subtract 4 to get our answer. So now we have to undo these in the opposite order. So I look to my side with my variable, and what's farthest away is my minus 4. So the first thing I'm going to undo is my minus 4. I'm going to undo that by doing the opposite. I'm going to add 4 to both sides. The minus 4 and the plus 4 give me 0, so I just put a big 0 around them and I write what's left. I've got x over 8, which is x divided by 8, equaling, and then negative 5 plus 4 gives me a negative 1. So now I have a problem that looks very similar to our work from yesterday. I look to my side with my variable, and you'll notice that 8 is still attached to x. We want to get the x by itself, so in order to undo dividing by 8, we're going to take both sides and multiply by 8. As I mentioned yesterday, we can reduce the 8's to 1 because if we were to multiply, we'd end up with 8x over 8, and 8 over 8 is 1. So here we're left with x equals, and negative 1 times 8 would give us negative 8. If we wanted to check our answer, we could go ahead and plug back into the original equation. So if I came over here, I've got negative 8 over 8, which is negative 1. Bring down the rest, minus 4 equals negative 5. According to our integer rules, we're going to keep it, change it, flip it, and negative 1 plus negative 4 is negative 5, so we know that we have the correct answer. So on this next problem, we again look to the side with our variable and we ask ourselves, what's the furthest away? The furthest away is our minus 5, so I'm going to undo that by, that didn't show up, adding 5 to both sides. The opposites are 0, so I put a 0 around them. We have negative 4m equaling negative 37 plus 5 is negative 32. Again, we still have something connected to our variable. We've got a negative 4. Now, when a number is right next to a variable, they're held together by multiplication. And in order to undo multiplication, we have to divide. So I'm going to divide by negative 4 to undo that negative 4. Negative 4 over negative 4 is 1, which is exactly what we want. We want 1m. And that's going to equal negative 32 divided by negative 4. A negative and a negative is positive, and 4 goes into 32 8 times. So we get m equals 8 for our answer. If I wanted to check over my work, I could come up here and plug 8 in. This gives me negative 4 times 8, which is negative 32. Bring over the rest, minus 5, and we're checking to see if that equals negative 37. So if I keep it, change it, flip it, I have negative 32 plus negative 5, which gives me negative 37. And it works out. On the next slide, we can start with problem 1. We first look to the side with our variable, and what's furthest away is our plus 1. We're going to undo our plus 1 by subtracting 1. To get rid of that, we have opposites which give us 0, so we're left with 4x equaling 16. The x still is not by itself. It's got a 4 connected to it by multiplication. So in order to undo multiplication, we're going to divide. When we divide by 4, we get 4 over 4, which is 1x, and that equals 16 divided by 4 is 4. Again, I'm going to go back up to the top and I'm going to check over my work. 4 times 4 gives us 16, plus 1 gives us 17, so it checks out. Problem 2, if we look over here, what's farthest away from our x is this minus 2. So in order to get rid of this minus 2 or negative 2, either way that you look at it, we have to write down the opposite of it in order to get rid of it. So in order to get rid of our minus 2, I'm going to put a plus 2 below it. I also have to put a plus 2 on the opposite side of the equal sign. The reason I can get rid of these is because the answer is 0. Negative 2 plus 2 is 0. I'm going to bring down what I have left. Don't forget to bring down your negative sign or your answer is going to be the opposite of what it should be. So we have negative 2x equals negative 14 plus 2 is negative 12. I'm going to divide both sides by negative 2 because the negative 2 is connected to the x by multiplication, and in order to undo multiplication we have to divide. Negative 2 divided by negative 2 is 1x equals, a negative and a negative is a positive, and 12 divided by 2 is 6. So what I'm going to do is I'm going to plug that back into my equation. Okay, when I plug that in up here, we have to, I'm going to write it down here so that it's a little bit more clean. We remember our order of operations. So when I'm solving this, I have to do my multiplication first. So 2 times 6 gives me 12. I'm going to bring down the rest of the problem and check to see if it works. Negative 2, keep it, change it, flip it. Negative 2 plus negative 12 is negative 14. We got the correct answer. The best part about this is you can always check over your work and guarantee that you have 100 just by plugging back into the original equation. Moving on to problem 3, again, we're going to look to see the side with our variable. What's farthest away from our variable is this negative 3, and in order to get rid of that negative 3, we need to create the opposite. I'm going to put a plus 3 below it because that creates the opposite. Negative 3 plus positive 3 is 0. I'm going to bring down what I have left. 2v equaling 10. Now I still have a 2 connected to my v by multiplication, so I undo that with division. I'm going to divide both sides by 2. 2 over 2 is 1. So I get v, 1v equals, and 10 divided by 2 is 5. I can go through the check by writing down my original equation and checking to see if I get 7 for my answer. 2 times 5 gives me 10. I'm going to bring down the rest. Negative 3 plus 10 does give me a positive 7. So this one works out. Now on problem 4, it is assumed that the n plus 5 is grouped together in parentheses. So in order to undo things in the reverse order, the first thing we have to get rid of is this dividing by 3. To undo dividing by 3, you're going to multiply both sides by 3. Well, these 3's, this is like 3 over 1, so these 3's are going to cancel off, and we are going to be left with n plus 5. On the other side, 2 times 3 gives us 6, so this is what we are left with. Our n is still not by itself. We've got a plus 5 connected to it. To undo that, we're going to subtract 5 from both sides. And in this case, we get n equaling 1. If I were to plug back into my equation, I have 1 plus 5 over 3. The rule says we have to do the top first. 6 over 3, and we do get 2, which is what it said we should get. Now I want you to realize that these two equations are different. The one on the left has the n plus 5 grouped together on the top of the fraction bar, which is why we get rid of that addition last. But on the one on the right, you'll notice that the plus 3 is off to the side by itself. Since it's off to the side by itself, we want to get rid of it by subtracting 3 right off the bat. To get rid of a positive 3, we subtract 3. That gives us 0. And we're left with x over negative 2 equaling 5. The x isn't by itself. It's divided by negative 2. To undo that, we multiply by negative 2 on both sides. These two cancel off because they equal 1. And x equals negative 10. If I wanted to check over my answer, I could plug this back in. I'm going to just plug it in right up top. Negative 10 over negative 2 gives me a positive 5. Let me bring the rest up. And 3 plus 5 equals 8. So it works. Number 6, we have to realize that with order of operations, we would have to do the parentheses first and then we would multiply. So since the last thing we would do is multiply, we're going to do it in the reverse order this time and get rid of our multiplication first. To get rid of, remember, when the negative 12 is outside of the parentheses, they're connected by multiplication. So to undo that, we're going to divide. I'm going to first divide the left side by negative 12, then divide the right side by negative 12. Negative 12 over negative 12 is 1, which leaves us with what's left in parentheses, the x plus 8. Next, we've got negative 240 divided by negative 12. Well, one thing we can remember is that a negative and a negative is a positive, so we can ignore those now. And then 240 divided by 12. The way I think of this is 12 goes into 24 twice, and then I put my 0 back. Now we have to get our x by itself. To do that, we have to get rid of this plus 8. We're going to get rid of the plus 8 by subtracting 8 on both sides. This zeroes out, and we're left with x equaling 20 minus 8 is 12. If I plugged back in, order of operations would tell me to do parentheses first. 12 plus 8 gives me 20, and 20 times negative 12 gives me negative 240. So my answer works out. On number 7, the farthest thing away from our v but is still on the same side, is our minus 11. We first want to get rid of our minus 11 by putting plus 11. These zero out. We're left with v over 16 equals negative 12 plus 11 is negative 1. What's connected to our v still is our divided by 16. To undo dividing by 16, we're going to multiply by 16. The 16s cancel out because they're 1, and v equals negative 16. To check our work, I'm going to plug in negative 16. Negative 16 over positive 16 is negative 1, minus 11. We keep it, change it, flip it, and we get negative 12. So we know that our answer is correct. With number 8, what's farthest away but still on the same side as our variable is the minus 9. To get rid of our minus 9, we're going to add 9 to both sides. This zeroes out because they're opposites. We're left with p over negative 2 equaling negative 9 plus 9 is negative 2. What's still connected to our p is our divided by negative 2. To undo dividing by negative 2, we're going to multiply by negative 2. The negative 2's here cancel off. We're left with p equals negative 2 times negative 2 is a positive 4. If I wanted to check, 4 divided by negative 2 is negative 2 minus 9. We keep it, change it, flip it. Gives us negative 11, so that one works out. A reminder for number 9, since these two here are connected by multiplication, I'm going to undo the multiplication by dividing. So I'm going to divide both sides by negative 3. Negative 3 over negative 3 is 1. I'm left with negative 11 plus m equaling negative 16. I have to get rid of my minus 11, so I'm going to add 11 to both sides. And this zeroes out, m equals negative 5. If I want to plug it back in, I'm going to come up top here and plug in my negative 5. Negative 11 plus negative 5 is a negative 16. And negative 16 times a negative 3 is a positive 48. Last two problems. These are the ones where we have the large fraction, so we have to remember to get rid of that division first. On this one, I'm going to multiply both sides by 5. The 5's cancel off. I'm left with 11 plus n equals 35. To get rid of my plus 11, I'm going to subtract 11 from both sides. And n equals 24. Number 11, I'm going to get rid of my divided by 14. I'm going to multiply both sides by 14. These cancel off. N minus 4 equals Negative 2 times 14 is negative 28. To get rid of my minus 4, I'm going to add 4 to both sides. So in this case, n equals negative 28 plus 4 is negative 24. If you have any questions, feel free to email me, and I can hopefully answer them. Thank you.